academic decathlon. That was a sneeze. It kind of scared me. Academic decathlon. For math, this is worksheet number 5, dealing with linear equations and quadratic equations, parabolas, lines. All right. Fill in the table, create linear equations in various forms. We're going to have to write it in slope-intercept form, point-slope form, and standard form. So first of all, let's write each of those. So slope-intercept is y equals mx plus b. You're given the slope, and you're given the y-intercept. Point-slope form. Point slope looks like this: y minus y sub 1 equals m times the quantity x minus x sub 1. So you are given a point, y sub 1, x sub 1, and you're given the slope, which is m. And then standard form is ax plus by equals c. And only thing that they stand for, x and y, are the points, is a point. So create an equation, the line contains that. So the first thing we're going to do is we're going to find the slope. So find the slope. And the slope is y sub 1, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is your first point, so this is x sub 1, y sub 1. This is your second point, so this is x sub 2, y sub 2. So 8 minus negative 1, 2 minus negative 1. That gives you 9 over 3, which simplifies to 3. So we can start filling in pieces of that puzzle. We can pick any point. We'll take y sub 1, so you can do y minus y sub 1, which is negative 1, which will make positive 1, equals 3 times the quantity x plus 1. And that would be the point slope form. Standard, we'll get to that later. We'll use our slope intercept. So find the slope. Now we're going to use part 2 is find the y-intercept. By using this equation, y equals 3x plus b, and we're going to pick a point. We'll pick that point negative 1, 1, using negative 1, negative 1. So we'll put negative 1 in for y, because that's my y value, times 3 times my x value, which is negative 1 plus b, equals negative 3 plus b. And then we'll add 3 to both sides to get 2 equals b. That's my y-intercept. So I'll go back here. I've already forgotten it. 2, so plus 2. That's the equation in slope-intercept form. This is the equation in point-slope form. You could have used the other x and y for it. There are an infinite number of equations to represent the line in point-slope form. There's only one equation to represent the line in slope-intercept form, and there are an infinite number of ones that you can use for standard. So we're going to take our slope-intercept form. So 3 is solve to standard form. So standard form, because the format is ax plus by equals c, we're going to get x and y on one side and get our constants, and then there are a couple things we need to know about. A, b, and c must be integers. And a must be positive. So if we have our equation y equals 3x plus 2, we got to get the x on the same side as the y, giving us negative 3x plus y equals 2. Now, a, b, and c. A is negative 3, b is 1, c is 2. All are integers, but a must be positive. So I'm going to multiply this entire equation by negative 1, giving us 3x minus y equals negative 2. 3x minus y equals negative 2. 3y minus y equals negative 2. And those are the three formats. Rewrite the linear equation. Okay. So we have 3y plus 2x equals 8y plus 15. Let's move the y's over. Giving us negative 5y plus 2x equals 15. Let's minus 2x. Negative 5y equals negative 2x plus 15. Let's divide everything by negative 5. Giving us y equals 2/5 x minus 3. That is slope-intercept form. Now we can write it in standard form. And we don't have to go back to this. We can actually go back to the original one because we're kind of close. If we want it in standard form, we're very, very close there. Negative 5y. I'm going to write the x first, actually. Excuse me. I'm going to write 2x minus 5y equals 15. And that would be standard form. That's okay. Now, point slope form, I'm not sure if they do want that, but let's pretend they do. So this is slope-intercept. This is standard. And remember, y minus y sub 1 equals m times the quantity x minus x sub 1. So we need a point. So we can plug in a point here, or we can find a point using our other equation. So you have y equals 2/5 x minus 3. If I plug in 5 for x, so I'm going to use the point 5, comma. So if we put 5 in there, 2/5 times 5 minus 3 gives us, that's an equal sign, gives us 2 minus 3, y equals negative 1. So 5, negative 1 is our point. Now we plug it in, plus 1, because opposite of my y value, equals m. My slope is 2/5 x minus 5. And that would be the point slope form. So using the information earlier helps us find it. Write the equation on the line containing tend 0 with a negative rate of change of 1 vertical step for every 2 horizontal. So a negative is either going to be down 1, right 2, or it's going to be up 1 and then left 2. So both gives us rise negative 1, run 2, or rise, run, and both are the same number, so it has a slope of negative 1/2. So we can use point slope. So y equals, sorry, not y equals, y minus, y minus 0 equals negative 1/2 times the quantity x minus 10. That was my point, 10 comma 0. So that gives us y equals negative 1/2 x plus 5. And here is our slope-intercept form. Here is our point slope form. And then if we want to put it in standard form, we could do that. Not sure if we need all three very, very formats. So we'll take y equals negative 1/2 x plus 5. Let's add 1/2 x, add 1/2 x. You get 1/2 x plus y equals 5. Remember, a, b, and c must be integers, so I got to multiply this by 2 to get rid of that fraction, and that would give me x plus 2y equals 10, and that would be standard form. Create the equation of the parabola containing the points -4, 6, 3, 6, and 2, 0. Remember, we get the formula ax squared plus bx plus c equals 0. Oh, equals y. Hello, excuse me. Equals y. Hello. Equals y. So we're given x and y. So a x b x plus c equals 6. And we can simplify this. This gives us 16a minus 4b plus c equals 6. And we're going to use this equation a little bit later. And then we're going to take the other point. So we're going to have a times 3 squared plus b times 3 plus c equals 6. And so that gives us 9a plus 3b plus c equals 6. And if we subtract these two from each other, if we subtract them, subtract that quantity, 9a plus 3b plus c equals 6. If we distribute that out, that's a minus 9, that's a minus, minus, and minus. So that would give us 7a. That would give us negative 7b. These would cancel and these would cancel, equals 0. And now we have one statement without the c, which is good. And we can take that third equation and plug it in there. And that's going to be a times 2 squared plus b times 2 plus c equals 0, giving us 4a plus 2b plus c equals 0. And we can subtract these two from each other. And that would be 9a plus 3b plus c equals 6 minus 4a plus 2b plus c equal, sorry, didn't mean to have that parenthesis just yet, equals 0. So subtracting that negative, 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 so that gives us 5a. This gives us plus b. These cancel, equals 6. And now I have two equations. And let's do, well, let's solve for b and substitute it in, right? We have systems of equations. 7a minus 7b equals 0. We'll solve for b. We get b equals negative 5a plus 6. Let's take that and plug it in for b. So 7a minus 7 times negative 5a plus 6 equals 0. 7a plus 35a minus 42 equals 0. And now we're left with one variable. That variable is 42. 42a minus 42 equals 0. Add 42. Add 42. 42a equals 42. Divide by 42. We get a equals 1. We can go back to this one. And now we see that a is 1. We get b equals negative 5 plus 6. We get b equals 1 also. And then we can go back to, where's my c equation? We can take any of the c equations and we can plug in. Let's take this one. Let's take that. Let's not alone. Let's take that. Okay, we'll take that because it's copy, because I can select it. Stop with the recognizing. All right, let's paste. Let's move it, and now let's substitute our values. We have A equaling 1, B equaling 1. We're solving for C. 9 plus 3 plus C equals 6. 12 plus C equals 6 minus 12 minus 12. C equals negative 6. There's my third value. And now we can go back to this equation, ax squared plus bx plus c, giving us the equation. A was 1, I think. B was 1. So x squared plus x, I think this is negative 6, minus 6 equals y. That would be our equation for the point, or for the equation that contains these points. If I plug these points back in, I should get true values. Create the equation of parabola containing the points negative 1, 6, 0, 0, 1, 0. We can do that again. I'll show you another way. This may or may not work, but we'll still use ax squared plus bx plus c equals 0. Oh, not 0. I keep saying 0. Sorry. Equals y. Since this parabola has a point at 0, 0, and 1, 0, I know that it's either going to be upside down or right side up. And I know that this probably wasn't. I know my axis of symmetry is going to be 1/2. And your axis of symmetry equals the opposite of B over 2A. So I don't know if that really helps me. I know that has to be 1/2. Nah, doesn't really. 0, 0, y-intercept's going to be 0, so my c is 0. Nah, we'll go back and use the same technique. I don't know if that was really, well, we won't have to delete that. So we'll do it again. A times negative 1 squared plus b times negative 1 plus c equals negative 6, giving us a minus b plus c equals negative 6. Let's write the other equation. A times 0 plus b times 0 plus c equals 0. And that simplifies to c equals 0, which we knew. So that's nice, actually. And then we'll do the third equation. And the third equation is a times 1 squared plus b times 1 plus c equals 0. And that gives us a plus b plus c equals 0. We know that c is 0, so we can simplify those two equations to a minus b equals negative 6. And we can simplify that to a plus b equals 0. If we add these, we get 2a equals negative 6. Divide by 2, divide by 2. A equals negative 3. We have a, b. Now we can plug this in to find our other value. A minus b equals negative 6 when a is negative 3. Minus b equals negative 6. Let's add 3. Negative b equals negative 3 multiplied by negative 1. B equals 3. So my equation is going to be y equals negative 3x squared plus 3x. And that's it, because c is 0. And you wouldn't say plus 0. So there's your equation for that parabola containing those. Create an equation, the parabola containing the vertex 3, negative 2. So here we can find that this is our vertex is h value and k value. So, and then we have a point. So we can say 5 equals a times No, 5, 14. Sorry. 14 is my y value. That's my y value. This is my x value. This is my h. This is my k value. A times the quantity x. No, God, Rob. Getting tired, sorry. 5 minus 3 quantity squared plus or minus k minus 2 plus 2. And we get 14 equals a 2 squared minus 2. 14 equals 4a minus 2, add 2. 16 equals 4a, divide by 4. 4 equals a. Now we can write the parabola, the equation for it. The equation is going to be y equals 4 times the quantity x minus h, so minus 3 plus, no, minus 2, minus, quantity squared, minus 2. H and K, yes, X value, Y value, and that is the vertex form of it. If we wanted to write it in standard form, you would write Y equals 4 times the quantity. We can square that. That's X squared minus 6X plus 9 minus 2. Distribute the 4 before doing the 2. 4x squared minus 24x plus 36 minus 2. Y equals 4x squared minus 24x plus 34. And then you could factor out a 2. No. Well, you could, no, I think that's just it. And that would be in standard form. These are the same equations. Good. Given the table, determine a linear or quadratic. We can graph it, or we can see that the rate of change is constant. If the rate of change is constant, so that is plus 2, this is plus 1, this is minus 8, this is minus 1. So if we write it as a slope, y over, you get negative 8 over 2 and negative 1 over negative 1. That's positive 1. So a slope of 1, and this is a slope of 4, so it is quadratic because it's not linear. Linear equations would have a constant slope. This does not have a constant slope. Just making sure. I added 2, I added 1, I subtracted 8, and I subtracted 1. Yep, good. All right, let's check and see. Yep, depending on the point that you use, 3x minus y. These are the ones that I really wanted to see. Linears are fine. These are okay. This is the one that I wanted to see. Yep, that's good. And I'm pretty sure that was good. And this is good. I remember. Okay, so that's interesting. So let's look at that. Let's go. How did we get? Can we factor? We factor out? No, that would have gotten a 2. So that is x squared minus 6x plus 9. That's correct. And then you distribute and you get that. And you have the minus 2. Which makes that, well, I mean, right? Is that the correct equation? Let me just make sure that was the correct equation. Yeah. Minus 2. And then they say it's that. So what we can do is we can go on to Desmos. Let's go to Desmos. Let's take our original equation, y equals 4 times x minus 3, quantity squared, minus 2. That's our parabola. And then I thought it was y equals, what was it, 4x squared. What did I think? I don't know that. Get away from there. I thought it was minus 24x. Minus 24x plus 34. Yeah, it was just the same equations. That's good. And then is their equation, y equals, what was their solution? Their solution was x minus 2 plus 1, x squared minus x plus 1? No, plus 2. Oh, minus 2x plus 1. Minus 2x plus. Yeah, they're wrong. Oh, maybe this is to this. Yikes. Okay. Given the table, determine the linear. Oh, determine it. Sorry. I thought I said determine whether. Duh. Sorry. Okay. So we're not done. We gotta, we gotta do that same form that we did before. Sorry. It is a quadratic, and it is not linear. So let's erase that ink. Clear ink. All right, let's make our equations again. We got 3 equations. We've got a negative 2 squared plus b times negative 2 plus c equals 9. That's my x values. Those are my y's. So that gives us 4a minus 2b plus c equals 9. Let's do a times 0 squared plus b times 0 plus c equals 1. That's going to give us 0 plus 0 plus c equals 1. So c equals 1. We can change this now. 4a minus 2b plus 1 equals 9, giving us 4a minus 2b equals 8. And let's do the third equation, where you have a 1 squared, b 1, c we know is 1, and y is 0. So we get a plus b equals negative 1. A plus b equals negative 1. Let's multiply this by 2. Taking those equations, 4a minus 2b equals 8. This now becomes 2a plus 2b equals negative 2. Let's add them. 6a, these cancel, equals 6. Divide by 6. A is equal to 1. And let's use this equation. A plus b equals negative 1, where a is 1, plus b equals negative 1, minus 1, b equals negative 2. And yes, my equation ended up being y equals x squared minus 2x plus 1. And that was the equation for the parabola. Y equals x squared minus 2x plus 1. Yeah. Okay. Cool. Good. Fun stuff.